All right, fifth graders, today we are doing module 3, lesson 5. And we're moving on from what we were doing earlier this week. What was the main, if you had to summarize, if someone says, hey buddy, what are we doing in math right now? What have we been learning how to do? Jaden? Adding fractions. You weren't even here for the past 2 days, and you know that we've been adding fractions. Great. Today we're going to move on. We're going to do something related, but our learning goal says I can subtract fractions by using rectangular fraction models to make equivalent fractions. Okay, so let's break that down. What does rectangular fraction model? What's another word for that? Area model or picture. Good. And what about equivalent fractions? What does that mean?
Fractions that have the same denominator.
Fractions that have the same denominator? Fractions that have the same value. Thank you. The directions tell us to find the difference. When something tells you to find the difference, which mathematical operation do you need to use? Everyone? Subtraction. And then it says it was a. That's because it's a typo. It should say use a rectangular fraction model to show how to convert to fractions with common denominators. Okay, so up here I have 5/6 and 1/3. Yes? If I want to overlap them, I could draw, my thirds over here, and then my 6, 3, 4, 5 over here. Now let's write some equivalent fractions. Now instead of splitting this whole unit up into 6 equal-sized pieces, how many pieces are there? Well, I have 1, 2, 3, 4, 5, 6 in one row, and there's 3 rows, so how many are there all together? 18. And how many of those 18ths are colored in? 15. Very good. Now over here, I also split it into 18ths, right? But how many are colored in? 6. That means that 15 18ths is equivalent to 5/6, and 6 18ths is equivalent to 1/3. So if I wanted to rewrite this problem using like denominators, what could I write? Gia? 15 18ths minus 6 18ths. So what this question's asking then is if I have 15 18ths and I take away 6 of them, how many do I have left? 9 18ths, which is exactly half, yes? Let me show you what that would look like with the picture. It's saying that we're starting with these 15 18ths. That's what we're starting with. But we're going to take away 6 of them. We're going to take away, here's 1. We're going to cross out 1. I'm going to cross out another one, 2, 3, 4, 5, and 6. So after I cross out 6 of those 18ths, how many are left? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many are left? 9 18ths, and if you simplify it, it becomes 1/2. Okay, what is this word problem asking us to find out? Well, it wants us to figure out how much butter she had in the beginning, at first, okay? What we know is that she had 1/4 of a pound. She used 1/4 of a pound to make a cake. After that, she still had, this is what she had left over, okay? She had 5/8 of a pound left over. How can we figure out how much she had at first, before she even made her cake? Well, do you see how if we draw a tape diagram, it shows us we need to add the cake amount to what was left over? So we need to add 1/4 plus 5/8. Make sense? Okay. So from our rectangular fraction models, we can see that 1/4 is equivalent to 8 32s, or 30 seconds, and 5/8 is equivalent to 20 30-seconds. So if I wanted to rewrite this math problem, I could rewrite it as 8 over 32 plus 20 over 32. If I have 8 32s and I add 20 more, how many do I have? 28 over 32. Can I simplify that fraction? Yep. I can, because 28 and 32 are both divisible by
4.
They're both divisible by 4, aren't they? What's 28 divided by 4? What's 32 divided by 4?
8.
So the answer is 7/8, but I need some sort of unit. Let me give you a hint. Every time we do word problems, you'll need some sort of unit. What should the unit be?
Pounds.
Pounds. Good. Okay.